Livestock, which depend on predictable light cycles, might experience reduced fertility and productivity across generations. If Earth's distance from the Sun increased slightly, average global temperatures could plummet, creating mini ice ages in many regions. Species that thrive in warm climates would migrate toward the equator or perish under colder conditions. Reptiles, whose body temperature depends on their environment, could see dramatic population declines due to decreased sunlight. Amphibians, already vulnerable to fungal infections and habitat loss, could vanish entirely from certain continents. If Earth moved closer to the Sun, the opposite would happen. Deserts would expand, and many ecosystems would burn or wither. This heating could trigger more frequent wildfires, threatening large mammals and reshaping entire forests in a matter of years. Some animals might adapt by evolving rapidly, but others would go extinct before they had the chance to change. Human infrastructure built for a stable climate would buckle under the pressure of sudden heat waves or cold spells. Diseases could spread faster as insects like mosquitoes find new, warmer habitats to thrive in. Meanwhile, ocean acidification could worsen as temperatures rise, killing off shell-forming creatures like clams, oysters, and some plankton species. The resulting imbalance in the food chain could affect fish, whales, and seabirds, many of which are already endangered. Animals in polar regions like polar bears and Arctic foxes would be among the first to disappear if ice melts too quickly. If Earth's orbital shift causes longer seasons, hibernation cycles could fail, leaving animals vulnerable and starving. Earth's magnetic field, which is tied to its rotation and molten core, might also experience subtle changes due to orbital shifts. Migratory animals like sea turtles and pigeons that rely on geomagnetic cues could lose their ability to navigate. This would cause mass strandings, missed breeding grounds, and population crashes in species already fighting extinction. Insects that depend on the moon's position for navigation might spiral into extinction as lunar visibility shifts. Even nocturnal predators like owls and big cats might lose their hunting efficiency under new light and seasonal cycles. A slightly different orbit could alter wind patterns, changing how and where storms form and strike. More hurricanes, typhoons, and tornadoes would endanger both humans and animals alike, especially in tropical zones. Rainforests, which rely on consistent rainfall, might dry up or be blown apart by new wind directions. The Amazon, often called the lungs of the planet, could turn into a savanna, taking countless species with it. Insects like bees, essential for pollination, might fail to survive long enough to evolve or adapt to the changes. A chain reaction of ecological collapse could spiral outward from the equator to the poles in just a few decades. And yet, all of this stems from a simple hypothetical. What if a black hole slightly nudged Earth's orbit? The power of gravitational influence reminds us how finely tuned our planet's position is in the solar system. Even small celestial disturbances can reshape the natural world on every continent and in every ocean. The thought of a black hole changing Earth's path might sound terrifying, but it also reveals nature's interconnectedness. Evolution, migration, reproduction, all hinge on environmental consistency that Earth has enjoyed for millennia. Without it, the animal kingdom would enter an age of uncertainty, and human society would struggle to adapt. Domesticated animals like cattle and poultry might become difficult to raise due to new diseases and breeding challenges. Wildlife conservation efforts could be rendered obsolete as habitats shift too fast for protection strategies to keep up. Zoos and sanctuaries might become final refuges for species that can no longer survive in the wild. Natural selection would go into overdrive, favoring species that are flexible, mobile, or highly resilient to change. Opportunistic species like rats, raccoons, and pigeons might thrive while more specialized creatures vanish. Aquatic animals in freshwater ecosystems, like otters and frogs, would suffer as rainfall patterns and water temperatures shift. Rivers could dry up or flood unpredictably, endangering the animals and people that depend on them. Migratory whales, which rely on stable oceanic conditions for their massive journeys, might lose vital feeding grounds. Seals and penguins could see their icy breeding grounds disappear, along with the fish that feed them. Forests, which take decades or centuries to regrow, might not recover in time to support displaced species. Insects that support entire ecosystems as pollinators, decomposers, and prey would struggle to synchronize with flowering plants. Some species might move poleward or to higher elevations, but suitable habitats may not exist in time to save them. Biomes like the tundra or alpine zones could vanish altogether, replaced by invasive species from lower altitudes. Scientists might be forced to use assisted migration, relocating species manually to safer environments. But moving wild animals is risky. Many don't survive the stress, and ecosystems can be disrupted even further. Domesticated pets might also suffer, especially heat-sensitive breeds that cannot adapt to new climate extremes. Veterinary science would face new challenges as animals encounter unfamiliar pathogens and parasites. Even Earth's soil microbes, crucial for plant growth, could be thrown into disarray by changing weather and seasons. Fungal blooms might spread in new regions, affecting amphibians, insects, and even mammals in unexpected ways. Mass extinction events in Earth's history were often triggered by subtle climate or orbital changes, a reminder of our planet's fragility. The Permian-Triassic extinction, for instance, wiped out over 90% of marine species due to abrupt environmental shifts. If a black hole altered Earth's orbit today, we might be witnessing the beginning of another mass extinction. Conservationists would need to rethink every recovery plan as old habitats vanish and new ones form in unpredictable places. Satellite data would become crucial in monitoring changes in animal migrations, vegetation health, and climate feedback loops. Climate models would need complete overhauls to predict this new and chaotic Earth with even partial accuracy. Scientists might launch missions to identify the black hole's trajectory, trying to understand its long-term gravitational influence. Even minor orbit changes could continue affecting Earth centuries after the black hole has passed. Global cooperation would be essential to manage animal relocations, disease monitoring, and food supply chains. Zoos might become arks, preserving genetic diversity while nature reconfigures itself under the new orbital conditions. Farmers would need to pivot quickly to climate-resilient crops, possibly using CRISPR or other gene-editing tools. Aquaponics and vertical farming might become essential as outdoor agriculture grows less predictable with orbital shifts. For wild animals, conservationists might turn to drones and AI to track populations and design dynamic refuge zones. Ocean sanctuaries could be moved or expanded to protect marine species from warming and acidifying waters. We might see climate corridors built to help animals migrate safely through human-dominated landscapes. Despite the danger, some species would thrive, like adaptable generalists able to survive in new niches or diets. Coyotes, for example, already flourish in cities and could expand their range even further in a changed world. Insects with short life cycles might evolve new traits faster than longer-lived animals like elephants or whales. Evolutionary biologists would be flooded with data as natural selection accelerates and strange new hybrids emerge. Ecologists might discover animals forming surprising alliances or developing unique survival strategies never seen before. However, humanity might not act fast enough to preserve the balance that supports both animals and civilization. Political instability from mass migration and food shortages could hinder our ability to protect the natural world. In worst-case scenarios, nations might focus only on human survival, abandoning biodiversity protection altogether. But the collapse of animal populations would inevitably backfire, as ecosystems are foundational to food, air, and water. Without insects pollinating plants, Crops would fail even in artificially controlled environments. Without predators, rodent populations could explode, spreading disease and consuming massive quantities of food stores. Human health would decline alongside the planet's, as new zoonotic diseases emerge from distressed animal populations. Stress on Earth's biosphere could also reduce atmospheric oxygen production, especially as ocean phytoplankton die off. The black hole wouldn't kill us directly, but its ripple effects might weaken the planet's support systems. In this way, even a slight change in orbit becomes a global cascade of ecological, biological, and societal shifts. And yet, Earth has survived dramatic transformations before, including asteroid strikes, volcanic winters, and solar variations. Life has always found a way, though not always in the form we once recognized. In a post-black hole Earth, some species might evolve to become dominant in ways we can't predict. Humans might one day look out onto a world with giant, cold-resistant insects or heat-adapted marsupials ruling new continents. Or perhaps aquatic species would diversify rapidly, taking advantage of flooded coastlines and shifting tides. Future scientists might study fossil records of animals that lived before the great orbital shift, us included. It raises a profound question. How stable is normal, and how quickly could everything we know change forever? A passing black hole would be a terrifying reminder that Earth is not isolated, but part of a dynamic universe. And sometimes the universe doesn't ask permission before shaking things up in spectacular, devastating ways. So far, no black hole is known to be headed our way, but the cosmos is vast, and surprises lurk in every dark corner. Astronomers continue scanning the skies, looking for rogue objects that could, with a whisper of gravity, rewrite Earth's future. Meanwhile, Earth spins on, orbiting the Sun in quiet precision, for now. But the next gravitational encounter might already be on its way, hidden behind a curtain of interstellar dust. If and when it arrives, will we be ready to adapt, or will we become another casualty of cosmic indifference? Ultimately, this scenario teaches us how fragile life is and how deeply it depends on cosmic stability. It also reminds us that animal life isn't just background. It's the thread that holds ecosystems and civilizations together. Whether we're talking about elephants in Africa or frogs in the Amazon, every species has a stake in Earth's stability. A black hole might not destroy the planet, but it could unravel the web of life that makes it beautiful and habitable. So we watch the stars, study the animals, and prepare, not out of fear, but out of wonder for the balance we call home. Because in a universe ruled by gravity and chance, Earth's delicate dance through space might be the rarest miracle of all.